All right. Good morning, everybody. We got to work on the enthusiasm. So, good news. Guess where we're not going to be next week? Here. So we have a week off, and I've actually made. When we'll talk about what's going on in the class, I went ahead and split this chapter up. We have a couple of assignments to do, and a little bit of work, but I did not put a discussion board in. Everybody loves discussion boards, and I also do not have a quiz this week. So hopefully we'll get done with this material. We won't have anything to do over spring break for you. So at least in this class, spring break will be a great, wonderful time without papers being needed to be written, assignments done, hopefully, and those kinds of things. So this week we start talking about strings and some of the interesting things we can do with those strings, because when we work with numbers, we have a one number, but a string is a whole series of items. And in fact, if we think about it that way, so in this slide here, if you think about it this way, hi there, each one of those strings has a position in that item. So what we're really making is kind of a data storage structure, and we can reference them by that subscript or where they are in that position. So I'm going to fire up idle real quick, if I can spell, because apparently I can't this morning. So there's a lot of ways we can start manipulating this. So if I want to know how long something is, and I can just put in there so if I do a length command, for example, it says, hey, you have 15 characters in there. So those positions I can say are 0, 1. So remember that we start counting at 0 is one of the harder things. So the furthest right is going to be a 0, and the furthest left is going to be 0. Or this is going to be a 0. This is going to be our 14 position. So we now can look at it and think about how we can start to break this apart. So we could come down here and do length of, and notice even though we say it's a number, it looks like in here, put that in quote marks so it'll know that it's a function. So that says that length is 3. So it doesn't say anything about the numeric value of it, but what it does is say what the value is in terms of a number. So if I did this, so I said length of 2, 3, 4, and I put it in as a number, it's going to say I don't length, these integers, they don't have a length. So I do have to make sure that I have the right type of item when I'm looking at it. But it's kind of nice because we can look at those subscripts and we can actually take a look at individual characters inside of there. So notice here, so I said name equals Alan Turing. So we can try one like that. Name equals, and I'm just going to be narcissistic. Put my name in there. So now I have a variable that's called name. And if I want to look at an individual character, and these are the square brackets right above the enter key in most of your keyboards, and I want to look at what the first letter is, which is really position 0, it pulls out that. If I want to do it as a different character, so I want to see what's in the 5th position, now I get the G out of there. So if I try to go outside of that range, so if I try to do name and I tried to do character, so we said it was however long it was, 1, 2, 3, 4, 5, 6, 7, 8. So if I went to 17, I'm going to get an error because we went to a position that there's nothing written in. So in other words, we were outside of this range of this particular item. So we can manipulate it in a lot of different ways. So we can figure out how long it is. So length of name. So we see it's 12 characters. So we can look at it, and it's a circular function, but I tend to not use those a lot. So the book talks about using some negatives, but I'm going to say let's not do that for right now. But what it can do, which is kind of nice, is we can create something like a for loop using that data that's in there. So for an index is just a variable we throw out kind of as a like an x, so you could say for x, for index, in range, length of name. So what this is going to do is it's going to go through every item in that particular name. So in this case, we said it's 12 units, so it's going to go 0 through 11. And then we could print that index so you can see what value it is, and then our name at a particular index. So I encourage you to try these examples in the book and see what happens. So it would help if I typed print right. So when I start to type and I'm talking, this is always a scary time. In range, and then we're going to print index. And then notice it did that. It put, so we could see the index value, and then it ran through that entire string of data. So that's kind of handy because we can look at an entire, that string as being an entire data unit. And so we can also do this idea of something called slicing. So slicing means we can take from one position to another. So let me put this up here where hopefully everybody can see it. So if I do the same thing over here, and now I'm using that colon character. So let's say I said name so name 0 to the end of the entire thing, that gives me that entire string. Name 0:6, let's see what it gives. So I can slice out pieces of that. So I could say name 6:10. So I can slice out pieces of this, of a file name or a file that we have in there. And that's pretty handy for what we're going to start doing here pretty quickly. So you can run through there to see if something exists in a name. So here we're going to show you something just a little different that we haven't yet. So we're kind of introducing a couple of concepts all at once. So let's scroll up a little bit so you can see. Do this. There we go. All right. So this very first thing they're showing you here is really creating what we're going to eventually call an array. So it's a group of items all stored in file list, and we access each one with a subscript. But the things we're storing here are names of files. So I'm just going to create it as it is. File list is equal to myfile.txt, myprogram.exe, your file.txt. So what we've done is inside of this variable called file list, we actually stored 3 different variables. And you could put in there and print file list to see what it's going to look like. And notice it prints out all 3 items for me. So it's storing all of those things inside of one variable. Well, I want to know if a particular item is in this list. Well, that for loop, and so we don't even need to call it index. So we could call it whatever we wanted to. So here they're calling it file name in. So inside of that structure we created, and then we're going to say if .txt in file name. So notice we've nested these in again. Print so I'm just going to do it that way really quickly to print success. So in this case it runs through and it says, hey, there's 2 of those files have .txt in them. So we can actually search through those that quickly. Almost every other language, we're going to have to come up with some kind of a construct to search through those individually. In this case, we just put this in this way, and it searches through all of those and says, oh, yep, that one was a success, that one was a success. And so we could have printed them at that particular point also, but we don't even need to do that because we can grab them there. So we could have also done all different kinds of other ways to search through there. So you'll see that, great, we can search through items pretty quickly. What I want to look at, and part of the reason I chose this book and some of the projects is I'm kind of a cybersecurity geek. The ideas inside of cybersecurity are kind of very interesting to me. And so what I want to do is see if there's ways I can use something like Python in the world of cybersecurity. And so one of the first ways that we're going to do something is we're going to actually look at a way to encrypt data. So think about a Caesar cipher. Wow, mind is gone. A Caesar cipher says, I'm going to replace a character with something that's so many characters away. So think of the alphabet on a wheel, and you're going to roll that wheel however many places you're going to say it is. So if I said I'm only going to change it 1 position, my A would now be a B, my B would be a C, my C would be a D. And so it's going to give a scrambled code just for that particular thing. So we can use the fact that we know that these characters are really represented by this idea of ASCII values between 0 and 255, but most of the characters we'll ever use are below 128. So we know that they're all hiding in there. And so here, if I moved them 3, so my value of 97 could go to 100. Well, we also have a really neat feature. So the ORD function returns the position in that ASCII sequence. Okay, so if I wanted to just, let me see where I put it there again. So I just wanted to run the ORD function. It's going to say Z lowercase is 122. If I say ORD capital Z, I hopefully get a different number, because remember, capitals and lowercase are different numbers. So I could also say then CHR, and if I put in a value, so if I put in 90, so I can flip those back and forth. So a cyber rotation, where did I put it? Somewhere in here is, let me drag this out of the way here temporarily. There it is. All right. So there are lots of sites online. So here they even have an alphabet kind of on a wheel. So we could actually check. So ABC, and if I shifted it 3 units, we can look at it this way. So there's ways we can change and decode and encode. So there's a lot of websites out there. Here's what's interesting. We have a Peru State College ad right in the middle of our page. That's kind of interesting. So Caesar cipher really means we're just rotating each one of those wheels. So we can do the same thing. So this particular, what we're trying to do is we're going to create a file that encrypts the input of strings, and then it takes that input and says that's my distance value. So let's take a look at what we've got going on here, and I'm going to do this to make life a little easier for me. Instead of writing this program in interactive mode, I'm going to create a new file. Move that out of the way. And I'm just going to use this simple text editor that's in here. So up here there's some text about what we're doing. I'm going to shortcut a little bit. I'm just going to say plain text. I'll use that one. And we're going to say input, enter a one-word lowercase message. Now, we're not limited to one word and we're not limited to lowercase, but for this example, we'll see where we can get to. And then distance, so in other words, how far around you rotate that wheel, we're going to take that as an integer. Enter the distance value. And all right, so now we're getting 2 values in. And so we're getting our plain text and we're getting in our distance. So now we can assign, so our code, we're going to say is going to be equal to blank blank. So that when we start this, we know that there's nothing in there to start with. Now, here's what we can do. So for character or CH in plain text, so each character in plain text, it's going to work its way through there. So here we're going to say ord value equals ordinance of CH. So what we're doing here is we're assigning whatever value is in here. So as it works its way through CH, each loop becomes, character 1, character 2, character 3, character 4. And we're assigning it into ord value. We're then going to manipulate it a little bit. And so we're going to say cipher value equals ord value plus our distance. I think that's what we called it, yes. So in other words, the first time through, if I put in Z as a lowercase, it's 90. It's going to come through and say, I wanted it 5 away. It's going to insert that in, and now it's going to become 95 for cipher value. Now, here's where it gets a little tricky. So our next line down we're going to look at, we're going to put an if statement in here. because I know I only want to go up to the end of the lowercase variables. And I happen to know my alphabet really well because they taught it to me in grade school. And so I'm going to say if cipher value is greater than the value of ord z. Now, I could just say 90 because we know it's 90, but we're going to let the computer do a little calculation. So if that's true, so in other words, I picked z and it changed it to 95, then we're going to cause it to rotate around backwards. So we're going to say then cipher value is going to be equal to the value of A. So in other words, our first letter in the alphabet we're going to use plus the distance so this looks a little complicated, it's not horrible. Minus ord value plus 1. Alright, so if I type that all right, and then our code up top then is going to be code equals code plus the character value for that cipher value. Alright, we'll work our way through here real quick. Oh, and that's got to be code, so once again, my typing fingers let me down. So in other words here, what we're trying to do is make this a circular function. So if that value exceeds z, we're going to rotate it back all the way around to 0, but we don't even want 0. We want it to go back up to where A is. So all of these are going to fit inside a 26 character space. So let's save and run this and see what happens. Yeah. All right. So if I run this, all right. Oop. Pops over here. So enter a one-word lowercase message. One word apple. So let's see. And I want to move it. I'm going to move it one space just so I can see pretty easily. All right. So I've done something wrong because I didn't get an output. So hang on. Let me go look. Oh, you know what? If I would actually put a print at the end of that, that would probably be helpful. Print code. So let me run it again. All right. So come over here. We're going to type apple. And the reason I'm just doing something like apple, I can see when I do it as one value. So A moving 1 over is B. P moving 1 over is Q, Q. L moving over is M and F. So we can create a way to scramble things using this idea of a rotation. Now here we've limited it. So here we've limited it to only those values between A and Z. So that distance we get in, so we're going to just move them around again. So this is an easy way to do that. So you can test this a couple of different ways. So you can run it and you can put in, to test it, put in a distance value of 0 and it should give you apple back in. We could run it and try a value that's really extreme. So apple, we could put in 90. And so now, notice it gives us these weird characters that are out of the range that we're looking for. So this program has an issue in that once we go past 26, it doesn't know what to do because we've got more than the letters of the alphabet. So we can see that there's some logical errors, but we're getting a start on how do we start manipulating these ideas of strings and values. So, all right, so a couple of things about this particular code. So here's what I'll say about it. It's interesting. It's very similar to what you probably did at some point as a kid where you wrote down all the letters of the alphabet and you wrote down a number or you wrote down a different letter and you just kind of rotated those around. So the problem with it, one of the problems with it is this. So in our one-word message, so something like Mississippi, and I'm going to move it 4 units. What it doesn't do is change the frequency of those letters occurring. Could you guess pretty quickly what something is just by that frequency? And in fact, we can find frequency distribution charts in almost any language. So you could look at So let's find one here. So if I look here, I could use this frequency count. So here we say, essentially 12% of all letters are E in the English language when we write out documents. So I could guess that Z, well, probably the least popular at 0.07. So if I have a bunch of text that's converted over, but we don't do a lot of other things to it, that frequency analysis will very quickly tell us where we can start substituting. And with something as simple as this, if I figure out how many positions away the E is, because I find the value that's most common, and I plug an E in there, and I say, oh, that's 5 positions away, I can then find the rest of that code pretty easily. So that's not what we use today. We use some other tools and other pieces, but it's kind of interesting to see how that works. Now, before we had computers and before we had other things, so some of the other ones we do use some matrix manipulations, and we're not going to go into a ton of the math in there, but it gets a little ugly when we start doing some bigger ones. So in cybersecurity, we talk a little more about it. So we need to be aware of where we're at in those. So positional values, make sure you've read about those. Binary, we're going to start talking a little more about binary because it's going to get kind of interesting. So we can make files where we can divide things up and create our own binary to decimal and decimal to binary converters. So here's, for example, of a way we can convert from a decimal to a binary simply by repeatedly dividing the same way we do by hand. So we're not going to grab that quite yet. So what I'd like to look at really quickly is our assignments for this week. So there are 3 assignments this week. Programming exercise 4.1, 4.2, and then a assignment you're going to turn in Python where we're going to build a clock. That's it this week. And I'm going to talk about some other things. So there's some links to another book in here that has some interesting ways, and then a logical error, which we're going to run into a lot. So I'm going to look at our first problem and see if we can come partway. There it goes finally, somewhere. If we can come up with somewhat of a solution for 4.1. Now, what I weirdly see on mine, it shows up in the grade book and it's getting a grade, but down here it says you will not be graded, and that's actually incorrect in this particular one. Thank you, Cengage, for making our life miserable. So this looks really familiar with what we just did. Enter a message, enter the distance value, and then it outputs a value, but should work for any printable character. So printable characters are typically 0 through 127 in ASSCII. No, I didn't mean to type it quite that way. So typically 0 through 127. So we can use anything from 0 to 127. So that puts some of our manipulation maybe a little easier than rather saying a particular character of the alphabet. Script would work for any printable characters, and output is listed. Okay, so I'm going to go back and look at what we just did, because I think some of the pieces that we did might be able to be applicable here. So certainly I can probably grab my inputs. So I'm actually going to copy those real quick. Notice I'm doing a little cheating here. So plain text. We don't need to reinvent the wheel. We've already done pieces of that. And a lot of times what we're going to do is modify that a little bit. So enter a message. So enter a message. Enter the distance value. So I already have parts of this put together. Well, that's kind of nice. I can get that then. And I know that I'm going to form a loop that's going to be very, very similar to what we did before. So I could use this. So for character, as I'm going to abbreviate, CH, in let's call that my plain text. So for character in plain text, same as what we did before, I'm going to create this loop that's going to loop through every character. So I have a couple of other things I need to do. So code, is I'm going to set it equal to blank so that we don't get confused. And then I'm going to use the same thing. I'm going to use ord value is equal to the ord, so the function ord of what we pass in each run of CH. So we're getting a little closer. We can say, all right, that's going to look very, very similar. So then we're going to add our distance in there. So whatever we're going to call that, that's supposed to be code. So our cipher value is equal to ord value, so what we just got above. So here if we got a Z, it's position 90, so we're adding 90 plus our distance, so how far around we're going to rotate it. All right. Here's where we come into where we can rotate that piece around a little bit. So I'm going to use that if statement again. So I'm going to say if my cipher value now, what I've added them together, is greater than 127, because I said 0 through 127 are the good characters. So if cipher value is greater than 127, I'm going to then say cipher value, I'm going to have to essentially rotate it back so it rotates around again. So I'm going to say cipher value is then equal to distance minus 127 minus ord value plus 1. So that rotates that around. So, and I kept them separate. Yes, we could take out the +1 and add it back over here if we wanted to, but this way it explains why we do that. Get rid of that starting at 0 position. All right. And then lastly then, I'm going to say code equals code plus whatever that character string was of cipher value. So in other words, we start here and we look at each piece and we convert it to its numeric value. And so one of the things we might want to do, just to make sure, is we may want to print ORed value right here. So we can see what's happening inside of something like this loop. And then, if you remember to, at the bottom, like I forgot to, then I'm going to print that code out. Now, I haven't made this pretty in any way. It's pretty ugly right now. But let's see if it runs. So enter a message. Enter the distance value. Alright. Oh. I must have had something really odd there. Hang on. Line 10. If site. Oh, yes. Yes, I did. Try that again. So, we just did that to take a look at those values. So, 84, 104, 101, 32, 115. So, and what you can see is THE, and then the blank space, THE, the blank space must be 32. So, every time I see 32, I know I've got a blank space in there. And then when it converted it, it turned it into that. Yeah. So we can run it again, or you can do something smaller. So Apple. Now, I can take out that print statement because it doesn't really do any good other than it's just showing us what's going on in there. So it's not a bad thing to have in there just to make sure we see that as it's looping through this group of plain text, that it's converting it. So, a couple of quick questions here. So one of them I usually get is, how long a message or how long a piece can you put in? Well, Python is really accommodating. So, for school to be Alright, that should be long enough. And the distance value, and it'll scramble that long of code. It'll store virtually everything we can type in there. There are some limits, but we're not going to hit them in the type of things that we are going to do. So, well, that looks like it scrambles it correctly, so let's go over and let's run our test. So, let's run checks. Holy cow, it did what we said. Let's give it 100%, and we're going to hit submit. So there's not a lot in terms of length to this, but it's kind of interesting in what it does. And if you want to make something that'll drive like your friends crazy, this is a great way to do that. Your own code based on just a Caesar rotation. you can certainly do that. So let's take a look at our other assignment for this week. So the other assignment then, there we go. Let's take a look at it here and what they're asking for. Write a script that inputs a line of encrypted text and a distance value and outputs plain text using a Caesar cipher. Yeah. So this really says we're going to do the opposite of what we did before. We're going to do the same thing to that string of characters, but now we're going to go the opposite direction. So we're going to decrypt it. Well, let me show you something kind of interesting. So let's see if I can get back to the previous one. Back. Oh, maybe I'll do it this way. All right, go back to exercise 4.1. So to give you a hint on where to start and how to do this, let's take a look back at our first one we did. Come on, load. There we go. So hopefully it saved it for me, or I'm going to be really sad. Come on. All right. So here's what I'm going to do. I'm going to run this. And so I'm going to run it, enter a message. And I'm just going to enter one letter. So I'm going to put a D in. And I'm going to move it 4 units. And it says I have an H. Okay, so keep that in mind. I have a D, I move it 4 units, and I get an H. So now I'm going to run it, and I'm going to enter my H. I'm going to take this distance value, and I'm going to put a -5 in. Let's see what happens. Nope, that's not it. So I'm going to run it again. I'm going to put an H, and I'm going to put in a -4. Because those are circular functions, instead of going to the right, I can write a program that's very similar, and it's going to take everything to the left. So we don't have to reinvent the wheel. You can modify a program like this and say, hey, I'm going to decrypt your message. What is my distance that we used before? And actually turn that into a negative and do the very same thing. Does that make sense? Yeah. That should give you a really good start on it, because there's not a lot of difference in the way you're going to do this. So the advantage to this is it's what we call a reversible cipher. In other words, what we do one way, we can do it again to get the other way. So you could come up with all different kinds of ways to do this. So one way that's kind of clever is if I know that I went 4 units to the right, that's actually the same as saying I went 131 units or whatever, because it's a circular motion. So this one, if you get number 4.1, 4.2 should be actually really a modification of that. You're not starting out with a completely new program to do that. Or at least I hope you're not. Because we want to take what we've learned and we want to be able to apply that then. So I will give you guys that as a hint for today. All right, I have a couple of more things really quickly I want to look at. So I'm going to copy this really quickly. So on all of the computers in here, I think it's all in here, I want to show you something that's another tool that we can put in your arsenal. So on your computer here, you probably have something called Notepad++. Notepad++ is a text editor, but on a little bit of steroids. So I actually prefer to use this, and I have some other tools I like to use, but when I do this, I get a couple of things that are kind of nice. So, File++, or Notepad++, I like the way it highlights text and the way it works for me in terms of finding values. So, if I'm going to create another item down here and I'm going to say code, notice when I start typing, it gives me blocks even. And I can do it all from the keyboard. So I really like a lot of the pieces that are in here. It is not the greatest Python editor. I will save that for some other ones because I don't want to give away too many things, but I like this as a general purpose editor for a lot of things. And so we have it here in our lab. If you've taken web design, you probably use this already. So notice that I can change languages. I can do, so if you look in here, it actually has, hey, I can change this to Python. So it'll automatically create some of the structures for Python for me. So notice when I do a loop down here, notice what it does over here on the left. It makes this little indentation. So I can actually close those up. So I can look at my mainline code and not get bogged down with, hey, I've got this loop I've got to do, or this if statement here. And that's one of the things I really like on longer code sections. It makes life a little easier to do. So there's all different kinds of tools. You can actually run macros inside of here. You can change your encoding. And it's got a lot of different tools inside of it. The best piece for me, and this is where this drives me crazy why they don't do that. Over here on the left, notice it numbers every line for me. Perfect. Over here, it numbers every line for me. Perfect. But when I do the simple text editor here, what am I missing? If I click on it and put my cursor on it, down at the bottom it tells me line 12, but it's not as intuitive. And for whatever reason, just because of things I've done or whatever in the past, I like to sit here and look at numbers beside me. Now, they're less important in this language than others, but I like to have that over there. That way, if I run into an error, then I can see it immediately and I can say, oh, okay, this is what I need to do. So, this is my hint of the day. You might want to try this. You can also, if you notice, if you're doing something else, so you're doing XML, it's got XML settings. Or you could do, maybe you're going backwards and you're doing AdaScript, so one of the first programming languages. Or maybe you want to do Fortran. It'll automatically do some of that formatting and things with you. It doesn't convert your Python code into code that'll run on Fortran, but it does a lot of the pieces for you in terms of what we're going to look at. So in just this one alone, you can see that there are hundreds of different things you can do it in. So if, for example, you've been over there running MATLAB, you can actually put it in MATLAB format. You guys use MATLAB over there? No. Okay. I was picking on you. There's actually one for R. If you're using R in terms of data, you can actually use R programming language. So there's a lot of tools available in Notepad++. It's free. The one thing I will say when you download and install this is they will want to include all kinds of quote-unquote extras. So be careful of that. But I think it will be a helpful tool for most of you as you start creating your code versus doing it in the simple notepad that's right here. Both work. I just prefer some of the tools that are available here, specifically the numbering, quite frankly. And I know that's a small thing, but I'm also very shallow and I can't handle cars with power windows that don't have automatic up and downs anymore. So that's the level of need that I have now. So I will leave you with that. We will look at 4-2 for a couple of minutes on Thursday. But what we're mostly going to do is look how we're going to build a clock And that clock is going to actually be part of your final project also. So make sure you look for that one on Tuesday as we come back in here. All right. Any questions for the live group? Any questions for the dead group? Okay, just checking. It was like, it's Monday and the weekend. You never know what happens with everybody. All right.